Welcome again. Today we'll get into the structure of the atom and the different types of radiation. We'll finish by looking at some exam style questions. Fortunately, I think this will end up being a bit of a shorter lesson today. What do you need to know? You must be able to describe the structure of an atom, as in what it's made of, and to describe the three main types of radiation. These are called alpha, beta and gamma. Again, you've got to be able to describe how they're made up and their sizes in comparison to each other. You must be able to state that unstable nuclei will decay into stable nuclei. Now, these words might not mean much to you just now, but we'll go over that. So atoms are tiny blocks of matter, like mega tiny. They are the building blocks of all the matter in the universe. Atoms themselves are made up of smaller particles called protons, neutrons and electrons. Protons and neutrons are small, but the electrons are even smaller than them. Protons and neutrons are roughly 2,000 times bigger than the electrons. The protons and the neutrons are bunched together in the centre of the atom. The central part of the atom is called its nucleus. Because the protons and neutrons are the larger particles in an atom, the nucleus is where most of the mass of the atom is. The tiny electrons are all in orbit around the outside of the nucleus, and they orbit at really high speed. The particles have an electrical charge. Now, you might have heard of electrical charge before, maybe not. It's covered in more depth in the electricity section of the physics course. All you need to remember is that the protons have a positive charge and electrons have a negative charge. The neutrons have a neutral or no charge. Because we find the protons and neutrons in the nucleus has an overall positive charge. You've got the positive protons, the neutral neutrons, and no electrons to cancel out the protons, so positive charge. So, a wee bit of background information for you detail fiends. People hear the word radiation and automatically get the fear, but it's an unavoidable consequence of being part of the universe we live in. The thing is, the forces that cause radiation are the same forces that bind atoms together. Without these forces, all of our atoms would just disintegrate and nothing could exist. Radiation is a natural part of our environment, and our bodies are generally pretty capable of protecting us from the low levels that we experience from the Earth's environment. Now, it's true that too much exposure to radiation can damage our health, but as long as we're careful, we can live a long and happy life without worrying about turning into the Hulk or something. Here's the periodic table of elements. It's a list of all the building blocks of the universe, all of the different types of atoms. Some are radioactive and some aren't. The thing is, most of the radioactive elements are towards the bottom of the periodic table. Now, why is that? As we move down the periodic table, the atoms get larger and heavier and more complex. The positively charged protons repel each other, because all things with the same charge do that. So if you bring two protons together, they'll want to push away from each other. What that means is that the nucleus has a tendency to want to break apart because of all the positively charged protons in there trying to push away from each other. And that would be really bad news for us and the end of our existence. But fortunately, there are other forces inside the atom that help to keep them bound together. Yay! It's this balance of forces that determine whether an atom will be radioactive or not. The larger atoms tend to find it more difficult to hold themselves together. So these larger atoms will break apart, and this process is called radioactive or nuclear decay. Because they're definitely going to break apart at some point, we call these nuclei unstable, and these unstable nuclei will decay until they become stable, and those internal forces balance each other out. So let's have a look at the radiations we'll come across in National 5. There are many different types of radiation, but the three main ones are alpha, beta and gamma. You need to know what each of them are made of and how they compare in size to each other. Alpha particles are the largest of the three. Now, don't get me wrong, they're still tiny compared to the objects that we experience every day, but in the world of particle physics they're pretty big. Alpha particles occur during alpha decay. During alpha decay, the nucleus spits out a particle that's made of 2 protons and 2 neutrons. Now in the periodic table there is an atom with 2 protons and 2 neutrons. Helium. And normally a helium atom is the electrons orbiting round about it, but we find the 2 protons and 2 neutrons in the helium nucleus. So another way of thinking about the alpha particle, because it's made of 2 protons and 2 neutrons, it's identical to a helium nucleus. A beta particle is produced during beta decay. A beta particle is a high speed or a high energy electron, and it's ejected from the nucleus. Because beta particles are electrons, they're absolutely tiny, much smaller and less massive than an alpha particle. But you might ask, electrons from the nucleus? I thought electrons were orbiting around the outside of the atom. Well, that's true, but during beta decay something strange happens to one of the neutrons. Let's pick this neutron here. For reasons that are way beyond National 5 physics, the neutron changes into a proton and an electron, and the electron's then ejected from the nucleus at high speed. We've come across gamma before, and gamma is the most energetic radiation from the EM spectrum, the electromagnetic spectrum. If you don't know what I mean by the electromagnetic spectrum, go and watch the video that I produced on the electromagnetic spectrum. I'll link it in the description. No particles are given out during gamma decay, it's just the nucleus releasing a little bit of energy in the form of a little burst or packet of electromagnetic waves. The official physics name for a packet of electromagnetic waves is a photon. So let's have a look at some exam questions on this topic. The first question asks, which row describes alpha, beta and gamma radiations? And you'll notice the little Greek letters next to alpha, beta and gamma. They are the Greek letters alpha, beta and gamma because these are all letters from the Greek alphabet. So have a look at your 5 options, pause the video and take a little minute to think. So alpha particles are made of 2 protons, 2 neutrons, that's a helium nucleus. Beta particles are electrons that are ejected at high speed from the nucleus. And gamma is a form of electromagnetic radiation. Your answer is B. Question 2. A student makes the following statements and gives 3 statements. Which of the following statements is or are correct? Pause the video, read the statements, have a think about your answer. So let's go through each of the 3 statements individually. The first one, in an atom there are neutrons and electrons in the nucleus and protons which orbit the nucleus. So that one's false because we find protons and neutrons in the nucleus and the electrons orbit round about. Statement 2, an alpha particle consists of 2 neutrons and 2 electrons. That statement's false as well because an alpha particle is 2 protons and 2 neutrons. And the third statement, a beta particle is a fast moving electron. That one's true, so only statement 3 is correct, and your answer is C. So quickly to go over the outcomes, describe the structure of an atom. We find protons and neutrons in the nucleus of the atom, and we find the electrons orbiting round about the outside. Describe the 3 types of radiation. An alpha particle is made of 2 protons and 2 neutrons. Another way of saying this is it's a helium nucleus. Beta particles are high speed or high energy electrons ejected from the nucleus during beta decay. And gamma radiation is just a little emission, a little release of energy, and gamma is a little emission from the EM spectrum. And lastly, you've got to be able to state that these large unstable nuclei will decay into smaller, more stable nuclei over time. If you've made it this far, my sincere thanks, and if you could like and subscribe, that would be great, and hopefully catch you next time. Take care, bye.